Hi, I'm Lewis Quayle. I'm a data scientist and bioinformatician and maintainer of lewisdoesdata.com, which is my website where I blog data science tutorials and guided data analyses. Today I'm going to do a tutorial that will focus on basic use of the core Tidyverse, which is a collection of R packages for data science, all of which use common data structures and share an underlying design philosophy and grammar. Whenever I'm asked to recommend a starting point for anybody wanting to do data analysis in R, the Tidyverse is generally what I recommend. So the first step that we're going to do is to run some setup code and load our dependencies. So we're just going to load the Tidyverse package. And the Tidyverse is a meta package which contains 8 other core packages which are detailed here along with their versions. And I've also included some code which sets up a custom plotting theme for ggplot2, which is one of the packages within the Tidyverse. All of this code will be available in the blog post which will accompany this tutorial on my website. So we can run all of that code and that will set up that theme for us. So the next thing to do will be to load the data that we're going to use for this tutorial. This data set's from the Tidy Tuesday project, which is a weekly data project aimed at users of the R ecosystem and is run by the R for Data Science online learning community. The data set that we've got contains the Billboard Hot 100 songs of the week for each week, dating back to the 1st of January 1966, and that can be found at this URL here. So what we're going to do is we're going to use the read_CSV function from readr in order to read the CSV file directly from this URL and store it in this df object or variable. So if we run that, that'll take a little while to load and then we'll have our data. So the Billboard Hot 100 is the music industry standard record chart in the United States for songs, and it's published weekly by Billboard magazine. Chart rankings are based on sales, which are both physical and digital, along with radio play and online streaming, all from the United States. So you'll see here that I've got a code chunk which is collapsed, which does some basic data processing. Now I haven't included this in the tutorial, we're going to skip over it for now. But what this will do is filter the data to include only entries after the year 2010. And also do some minimal data cleaning. And this cleanup should just help to keep the focus of the tutorial on the functions and not the data. But all of the code for this will be available in the blog post associated with this tutorial on my website, so you can follow along with that and have a look at how it looks. So the first thing to do is probably to have a quick look at the data set. So if we run all of these lines of code above, just to make sure that the data pre-processing is done. And now you'll see that we have this Billboard Top 100 environmental variable, which is our data frame that we're going to work with. So if I now run this view command, you can see that we can interactively view the data set. So looking at the data, we can see that there's a column for each date entry. We also have the song title and its rank for that week, which is shown here. The artist that made the song, and then we have some metrics related to the song's rank history and the number of weeks that it's been on the Billboard 100 chart. So just a good idea to have a quick look at the data to see how it looks before we get into analysing it. So the first concept that I want to cover here is something called piping, which is done with the pipe operator. This is something that you'll see a lot with Tidyverse packages. So the pipe operator, which is written % greater than %, is used for piping. And piping is where everything that comes before the pipe is evaluated, and then by default it's passed in as the first argument of the function that comes after the pipe. And piping is really useful for chaining series of functions together to keep code readable and also to minimize the number of variables stored in memory. So as an example, we could first look at how you might view the first 10 rows of your data set in the console inside using base R syntax. So if we wanted the first 10 rows, we would say give us the head of our Billboard Top 100 data frame, and we'd have to say n equals 10 in order to get the first 10 rows, because the head function will print the first 6 rows by default. So if we run that, we can now see that in the console output, we've got the first 10 rows of our data frame. With all the columns that we previously looked at when using the view function. So to demonstrate how piping works, we could say Billboard Top 100 and then the pipe operator, pass that into the head function. That's automatically passed in as the first argument, so it will be put in this position here. So all we have to do is say n equals 10, and then we get exactly the same output in the console. So another thing to mention with the pipe operator is that we can pass the output to a position other than the first by explicitly specifying the position that we want the output in using the period or full stop symbol. So we don't have to give the pipe operator a data frame, we could just give it the number 10, and then we could say head, and the head command requires our data frame as the first argument, and in this case, because we're not passing it in, we have to specify it. So what we're actually doing here is passing it the number of rows that we want, and instead of typing 10 here like that, if we pass in the number 10, we can specify that we want the 10 to land in this position here, so using the full stop. So when we run that, we get exactly the same output as before. Pipes can also be used inside functions, so you can chain series of commands together inside a function, and you can see examples of this in the data cleaning code included in the blog post. And the last thing that I wanted to mention is that you can insert pipes using a really handy keyboard shortcut, which is Control, Shift and M, which saves an awful lot of typing. So to move on, the first real tidyverse function that I want to look at is the select function, the first of 3 column operations that we're going to cover in this tutorial. So select selects the columns that you specify using either the index number, name, or a helper function, and it'll drop the remaining columns. So if we wanted to positively select certain columns using column names, we can say pass in our data frame, Billboard Top 100, to the select function, which comes from dplyr, one of the packages loaded by the Tidyverse. And then, for example, if we look at our previous console output, we could say we might want the date, rank, song, and artist, along with the number of weeks that the song was spent on the chart. So we could do that by asking for those columns explicitly. So we could say date, rank, song, artist, and then weeks on chart. So if what we're doing here is we're telling the select function to just give us back these columns. So when we run that, we will have dropped the previous week position and the peak position columns. So the select has a number of really handy operators and help functions which can aid in selecting columns. So a shortcut for what we've just done would be to start the command in the same way. So we can say select. But because in our data frame, because date, rank, song and artist are successive columns, we don't actually have to specify each one of them. We can say date and then using the colon symbol and then artist. And what this will do is it'll say give us date, artist and everything between those two variables. And then we also want the weeks on chart variable. So when we run that, we get the same output as we did previously, just with less typing. So another really handy thing that you can do with the select function is to rename columns inside the call to select. So we could say, using our previous example, we could say that we still wanted to select the same variables, so date through to artist, but we wanted to say rename weeks on chart to weeks. So we can use the syntax weeks equals weeks on chart, and when we do that, we can see now that we've renamed the weeks on chart variable to simply weeks. So just to deviate slightly, if you wanted to rename a variable without selecting, so if we wanted to keep our entire data frame but rename this week's on chart variable, we can use a function called rename which uses the same syntax as select, but we don't have to actually select columns because we're not wanting to drop any columns. We're simply just wanting to rename weeks on chart. So we can pipe our Billboard Top 100 data frame into rename and ask for it to rename weeks on chart to weeks. So now you can see that we have renamed the weeks on chart variable, but we have all the columns that we started with. So that's just a kind of a little bonus while I was on the topic of renaming. So something to mention is that it's also possible to select columns using column indices or numbers, so the numbers of the positions of the columns. So for example, date would be 1, rank would be 2, and so on. But this is a less good idea, because if the structure of the data frame changes, the output of your code would probably change, and explicitly using names means that you'll still get the same output irrespective of the relative position of the columns, assuming that those columns with that name still exist in your data set. So just something to mention there to be careful about. So we can also negatively select columns by dropping columns. So if we had a really large data frame, which we don't in this case, but if we had a really large data frame, and rather than selecting everything that we did want, we could just say drop columns that we don't want. So we could say we could drop the previous weeks on chart variable, previous week position variable, by simply using this minus operator. So when we run that, we'll have the data frame without that variable present. So if we wanted to use this same idea to get the data frame in the format that we had it before, where we drop both the previous week on position and peak position variables, what we could do is we could say we have to concatenate a vector using this C function. So we could say previous week position and peak position. And then, so we're concatenating those into a vector using the C function, and then saying, select, could you drop these two variables for us? So if we do that, we end up with the same 5 variables that we did before. And of course, you could then add on to the end of that to say weeks on chart equals week to rename as we did before, but we're not going to do that. So while the minus symbol does work, and you'll see this very frequently, which is why I've mentioned it, the most correct way of doing this is actually to use the not operator, which is the exclamation mark. So running that will give us exactly the same output. This is just the correct syntax to use. This is a bit more of an older, more of a hack way of doing things. So and all of these ways of selecting that I've just shown you will work with column indices, but like I said, generally it's preferable to select using the variable names. And the final way of selecting is to use selection operators and helper functions, which, if I was to go through all of those, would turn into a tutorial in and of itself. So I won't cover them here, but you can find a more comprehensive overview of the selection features for select in the help documentation. So you can get help if you don't know by using the help function. There's a few ways of getting help, but one way is to use the help function and then pass in the name of the function that you want help for. So if we run that, you can see that the documentation is brought up in this viewer window, and as I said, it details both the selection operators along with these really handy selection helpers, which help you easily select columns from your data. So what I'll do is I'll also leave a link to the cheat sheet for dplyr in the blog post that goes with this tutorial, so that you can get some more information about the selection helper functions, which isn't things that are additional to what's detailed in the help documentation. So one final thing to note before we move on is that we haven't actually been saving the output of the functions that we've been running. We've simply just been running them and printing the output to console. So if you did want to make some of the output available for later use in your code, you'd have to assign it back to a variable. But if you are going to assign variables, I'd strongly recommend that you don't assign the output back to a variable with the same name as that you use for the original data frame, because this can break your code. So if you consider the following: if we took our previous example, but we reassigned it back to a Billboard Top 100, so we can assign variables using this left assignment operator, this arrow, and if we then just paste in our previous example, what this is saying is run our code and then store it in this Billboard Top 100 data frame object or variable. So this would work, but if we tried running it a second time, we can see that it won't. And the reason for that is that it's trying to remove previous week position and peak position, but they don't actually exist in the Billboard Top 100 data object anymore, because we ran this effectively this drop command and then stored the output in this Billboard Top 100. So it's a good idea to always use different variable names when assigning output. So what I'll do is I'll just rerun all the code above so that we haven't got the Billboard Top 100 stored in an incorrect format. So now we should be able to run that. Yeah, that should still look the same as it did before. Yeah, great. So that's just really a word of caution about assigning variables. It's always good practice to use different variable names when assigning output. So we're going to move on now to look at the mutate function, which is another column operator in the dplyr package, and it's used to compute or append one or more new columns to a data frame. And like select, mutate can take any number of arguments, and it allows you to specify the name of each new column when doing so. So we're going to use an example where we might want to use mutate to add a column called collab to indicate if the song featured another artist as a collaboration. So if we look at our Billboard Top 100 data frame, we can see that there are certain songs where there are multiple artists listed using this string of characters featuring. So it's indicating that the main artist is Rihanna in this case, but it's featuring this artist Drake. So what we could do is we could say add a new column using mutate to indicate whether the song was a collaboration between two artists or not. So we could say mutate, and then we'll call the new variable that we're going to create collab. And then what we're going to do is we're going to use this function from the stringr package, which is another package which is in the Tidyverse. And we're going to say, look inside the artist variable for this pattern of characters, in this case featuring. And it will do that for every single row. So it'll look inside every row of the artist variable and try and look for this featuring string of characters. And if it's present, it will return true. And if it's not present, it will return false. And then it will it will assign that that vector of Boolean values back to this collab variable. So if we run that, we can see now that we've created a new variable where falses indicate that the string featuring hasn't been found, whereas true indicates that it has been found. So having just created this new column, we could alter the position, and there are a few ways of doing this, but for me the easiest way is to use the next function, which is called relocate. So we can use relocate to change column positions using the same syntax as select to make it easy to move blocks of columns at once. So if we take our previous example, and what we're going to do is we're going to move the newly created collab column. So the first argument passed into relocate, so if we say relocate, the first argument passed in is obviously the data, and then the next argument that we have to pass in is the column that we want to move. So we're passing in the data using the pipe operator that we covered earlier, and then we're saying move, in this case, this single column, but like I said, you can use the same syntax as select to specify multiple columns. And then there are additional arguments, either dot before or dot after. So I'll just move my cursor, we could say dot before, and that will allow us to move the column or columns that we've selected before another. And in this case, we're going to say dot after, and we're going to move it to after the artist variable. So if we run that, we can see now that we've moved collab from the end of the data frame to next to the artist variable, so that we can directly compare the two. Not necessary, but it might be helpful to do that. So that's just how the relocate function works. So let's move on to look at some row functions now. So filter is kind of like the row equivalent of select in that it's the staple function for subsetting. So we can use filter to extract rows from a data frame that meet one or more logical criteria. So we could adapt our previous example and imagine that instead of creating a new column, we just wanted to extract the rows in our data frame where the songs featured another artist. So I'm just going to lazily copy the code from the last example and remove that, and then I'll change that to filter and remove that. So what we know is that the strdetect function returns a logical vector, so we can use it along with filter to subset rows. So what we're saying is look inside artist, try and find this pattern, return trues and falses depending on whether this pattern's found, just as before. But instead of assigning the output to a new variable, we're then saying the filter function will just keep anything that evaluates to true and drop anything that evaluates to false. So if we run that now, we can see that the rows have songs where the artist only includes this featuring string. So it's only collaborations. So we can combine multiple statements in order to filter our conditions to meet the criteria, the exact criteria that we want. So in this case, we could say weeks on chart would be greater than or equal to 20. So what this will do is it will run the same. It will evaluate all of the entries in the artist column, but it will also say only give us those previous results where the weeks on chart is also greater than or equal to 20. So that's what it's done there. So that's an example of like combining multiple conditions using AND logic. But we could also return rows where one or the other statement is true. So if we said Billboard Top 100 and then pipe that into our filter function, we could say, in this case, we could say give us only artists where the artist is exactly equal to, say, Eminem, or the artist is exactly equal to Pink, for example. And I know I saw both of these two earlier. So if we do that, we now only have results for these two artists. And in fact, because we can't see Eminem in the output, I'll just show you that using it interactively that all of the results now scrolling through, looking in the artist column, it's only Pink or Eminem. So yeah, I won't scroll all the way to the bottom. But yeah, so that's how you can use OR logic to combine statements. So these are just a couple of simple examples of the filter function. And as with select, filter can be used with a large number of operators and functions in order to construct expressions that evaluate to vectors of trues and falses or Boolean values. So just like with select, I'd recommend that you consult the help documentation and the dplyr cheat sheet that I'll link to in the blog to really get a handle on how to use them effectively. So now let's look at our next row operation, which is the distinct function. So the distinct function extracts only unique or distinct rows from a data frame. So in fact, we could take our previous example to look at this, and we could say we want to filter for just Eminem and Pink, but also we want to see the song titles for each of these artists, just the song titles for each of these artists. So if we only filter as we did previously, so if we run this, whoops. So if we run that, we can see that there are lots of duplicate songs because the names of the songs were on the billboard for multiple weeks. So for example, if we look at this, Raise Your Glass, there are multiple entries in this week's on chart because it was in the chart for multiple successive weeks. So to just get the unique songs for each of these artists, we would have to use the distinct function. But just using distinct alone in this case wouldn't return the result that we were after, because actually each row does contain a unique series of a unique combination of entries for each of the variables. So what we would have to do instead is say give us the unique or distinct values for artist and song combined. So now we get just the artists, the unique combinations of those two variables, and that gives us the output that we were looking for. So just a quick note to also something that you might have noticed is that despite having asked for artist song, the results are returned in the format that they originally existed in the data frame, so song artist. And obviously if you really wanted to move those and change the order, you could use relocate as we did previously. So let's move on to look at our final row operation, which is the arrange function. And the arrange function orders the rows of a data frame by values of selected columns. So if we took our last example and we wanted to have the rows of the data frame ordered alphabetically according to artist, for example, we could add the arrange function to the end of that series of commands. So we could say arrange by artist. So if we run that, we've now got artist in alphabetical order. But note where there are ties, the songs are still just in any random order really. So we could say give us the combination of those two. So arrange according to artist first, and then when there are ties, also arrange song in alphabetical order. So we can see now that we've arranged artist in alphabetical order, but then for each artist, the songs are also arranged in alphabetical order. If you wanted to have your artists in reverse order, we'd have to wrap the name of the variable in this DESC function, which stands for descending. So we're effectively reversing the order. So now when we run that, we've sorted artist in reverse order of the alphabet. And in this case, because we didn't ask for song, the songs are still now just in random, in a more or less random order. But we could add a second to say give us the song in descending order as well. So now the artist are sorted in descending order, and then where there are ties, the song is also sorted in descending alphabetical order. Now obviously you can, if you wanted them in combinations of those, you can combine the various variables that you want to arrange by with this DESC function or not to get the rows in the order that you want them in. So we're going to move on now to look at a fairly important function, which is group by. And it's important because most data operations, when wrangling data, are actually done on groups defined by variables. And while these are a little bit more tricky to work with, they do become really powerful when doing data analysis in the Tidyverse. So the group by function takes a data frame and it groups it so that operations are performed by group. So let's imagine a scenario where we wanted to order the songs for just Eminem and Pink by the total number of weeks that each of their songs spent on the top 100. And you might think that we could just expand our previous example using arrange to include the weeks on chart column. So we could try that. So I'll just remove this call to distinct, and then we will add song and weeks on chart. Oops. So now what we've done here is we've arranged in order of artist, then song, and then arranged the song where it had multiple weeks on chart by that variable. But this doesn't, although it would allow us to see the final number of weeks on chart, it doesn't allow us to actually work with those data. So one approach to getting the output we wanted would be to group by the song and then extract the maximum number that's present in the weeks on chart variable. And we could do this using the group by function. So we can say group by artist and song. But just running this on its own will only group the data. So you can see now that we've got these intrinsic groups applied to the data, but it hasn't actually returned the result that we were looking for. And the reason for that is because we need to then actually operate on these groups in order to get the data that we want. And this is where our next function, summarize, comes in. So I'm just going to paste that example forward. So summarize is a function that creates a new data frame which contains one or more rows for each combination of grouping variables and one column for each grouping variable and summary statistic that we specify. So in this case, because we're after the total number of weeks from the weeks on chart variable, we could just say summarize and call our newly created variable total weeks. Oops. Total weeks, and we could extract the maximum value from that weeks on chart variable. So doing that summarizes the data and it gives us the data that we were after. And we could obviously then add a range in order to arrange in the descending order of the newly created total weeks variable in our summary data frame, and that would give us exactly what we were looking for. So the combination of songs by the two artists that we filtered for in the descending order of the total number of weeks that each song spent on the Billboard Hot 100. So that would allow us to achieve the goal that we set out to in our scenario. But there might be there are likely to be situations where you don't have a running tally. So we could actually use the intrinsic groups which were applied by the group by function in order to get the same data out, but instead of extracting the maximum number or the final number from a running tally, we could just say count the number of rows within each group formed by the unique combination of artist and song variables. So we can do that using this n function, and we don't in this case we don't have to pass it anything additional. And when we run that, we get the same output that we got before appending a range to the output of our code. So if we stole that line just to demonstrate this, and you add that on, you get exactly the same output that we did running the previous example. So that's a more common way that you will see group by and summarize used when we're wanting to count the number of rows. So there are shortcuts, further shortcuts to doing that, but we won't cover those here. And just before we move on, it's worth mentioning that there are a number of summary functions that can be used in Summarize to compute summaries of the data. Some of these are detailed in the help documents. Some are detailed on the dplyr cheat sheet. It's also worth mentioning that you can use your own functions to summarize data, but that's a topic that we could probably cover another time. So the final, I'm just going to copy this code, the final Tidyverse fundamental that I wanted to mention today is plotting, which is achieved using the excellent ggplot2 package. So we could make a quick plot for our summarized data that we've been working on. So let's imagine that we want to make a basic visualization of this summary data, and we would want to arrange just as we've done with the data, we want to compose a plot according to artists with songs ranged by the total number of weeks that they were on the Billboard Top 100 for. So if we take the previous code and we remove this arrange function to begin with, what we can do is we can pipe the output of our data wrangling into, I'm just going to insert an extra space for clarity here, but actually we could also be writing our code there. So we could say pass our output to ggplot, ggplot. So we're passing in the data as the first argument to ggplot, and the second argument to ggplot is a mapping. We have to create a mapping between the variables in our data and the aesthetic parameters that are used for plotting the data. So in this case, we would say x is the total number of weeks. So we're going to plot the total number of weeks on the x-axis. Y, we'll plot on the y scale, we'll plot the song, and on the fill scale, which applies some colour to, it's one of two ways of applying colour to the shapes that we use to plot the data. So in this case, we're going to say map the artist variable to the fill scale. So what we need to do now is add another layer to give us an actual shape to plot the data with. So note that in ggplot, we don't use the pipe operator, we just use the plus operator to add successive layers to the plot. So in this case, we're going to add a geom, which is a shape used to plot certain types of data, and in this case I'm going to use geom_col. So if we run that, we will end up with a plot shortly. There we go. So this isn't exactly what we want, but it's a start. So we've got our songs arranged, and they're actually arranged in descending alphabetical order here. And then we've plotted the total number of weeks for each of those songs, and we've coloured according, or filled the columns according to artist. So you can see that we've made a relatively serviceable plot just by adding 2 extra lines of code to the data that we'd previously worked on. But we could add a few extra lines of code in order to get exactly what we wanted. So the first thing to do would be to use the mutate function that we used earlier in order to rearrange the song variable according to the magnitude of the total number of weeks. So we want them in descending order on the actual chart rather than in descending alphabetical order. So to do that, we're going to use a function from the forecast package called fct reorder. And what this does is it reorders the levels of a categorical variable. So song is a categorical variable, and it reorders the levels and according to another function, and the default is the mean. So we're going to say rearrange the song variable according to the magnitude of the total weeks variable, and then assign that back to reassign that to the song variable so that they're then stored with an intrinsic order. And then we pass that into our plotting code. So if we ran that, we can see now that within artist we've arranged in descending order according to the total number of weeks that the song spent on the Billboard Hot 100. But we want to integrate these data with one another, so we want them mixed in the absolute order for both artists. So what we have to do in this case is we have to say dot groups equals drop. So there are a few ways of getting rid of the intrinsic groups that we formed using group by, but this is probably the easiest. So if we do that now, we have our data integrated. So we could add a couple of extra lines of code to sort of elevate our plot to a final blog ready stage. So we could say add some overwrite the colours which are used by default. Some perhaps more aesthetically pleasing, so we could say scale fill, because we're remapping the or we're reassigning colours to the fill scale that we've mapped artists to. So scale fill manual, because we're manually specifying the values. We're going to say values equals, and then we have to pick a couple of colours. So we could say pick a couple of colours that are appropriate for the artist that we've got in this case, and then we can add some labels which will not only overwrite the default axis labels, but we can also add a title and a subtitle so that our plot's a little more informative. So in this case, I'm going to say Eminem versus Pink for the main title, and then the subtitle will give a little more information, and I'm going to say time spent on the time spent by song, and I'm going to say, because I initially in the data pre-processing I initially filtered to the data that exists after 2010, so the data is 2010 to 2021, so I'll include that information in the subtitle, which has a typo in it, and then I'm going to overwrite the default x-axis label, which is the actual name of the variable that we used, and I'm going to call that just weeks, and then I'm just going to switch off the y-axis label, because it should be fairly obvious that these are the songs for each artist from the other information that we've included. And the final thing that I'll say is fill, which is the name of the scale that we map the artist categorical variable to. We're just going to use this as an opportunity to capitalize the legend title. So when we run that, we get a blog ready figure, which I'm pretty pleased with that for a few minutes work. So this has really just been a really simple demonstration of the ggplot function, which gives us the plotting capability of the Tidyverse. But plotting in ggplot2 is really a topic that requires a tutorial or series in its own right. If that's something that interests you, I have got a series of posts on my blog providing an introduction to the theory of ggplot2. And I'll probably be putting out some ggplot2 tutorials as a follow-up to those in the near future. So that really brings me to the end of this tutorial, where we've covered the foundational functions that form the basis for many data wrangling tasks in R. So I might do a few series or a few posts on more advanced functions and use cases at some point. And I have got a bunch of really handy tricks from the Tidyverse, and I'll definitely be doing a tutorial on those in future. So in the meantime, I hope you enjoyed this video, and I hope you have fun with your data analyses, and I will catch you next time.